Okay, so I'm going to teach Law of Cosines today, at least just some introduction how to do it. Basically, it's just a bunch of formulas. The first one, as you see here, I have Law of Cosines, and we have three formulas. The first one reads a squared equals b squared plus c squared minus 2bc cosine a. It's a mouthful, and then we have b squared equals a squared plus c squared minus 2ac cosine b. C squared equals a squared plus b squared minus 2ab cosine c for the last one. Usually, if you're doing Law of Cosines, they're already going to be in the book. Of course, you can look them up. If you're using the textbook from my classroom, it's going to be on page 437, section 6.2. Again, this relates to this kind of triangle. If you watch the Law of Sines, this is to find our triangles when we're only given either three sides or two sides and one angle. So side angle, side, 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 side. The other formula, I mentioned that if you head through all three sides, you can find the angle, is cosine A equals b squared plus c squared minus a squared all over 2bc. And then cosine B equals a squared plus c squared minus b squared all over 2ac. And the last one's cosine C equals a squared plus b squared minus c squared all over 2ab. Again, you can tell they're equivalent if we were to set them equal to each other, or not set them equal to each other, but as you can see from this one, I can see where I get cosine A and do some math functions with letters and stuff like that. So what I'm going to do today, I'm going to let if you're watching it, you want to get down the formulas, pause it right here so you can get down the formulas that you're going to be using. And then I'm going to do two examples. One where they give you two angles and a side, and then one where they give you all three sides. And then I'm also going to do Heron's area formula. I think that's how you say his name, Heron or Heron. Probably Heron's Greek guy. So I'm going to do an example of that one as well. So again, if you need the formulas, I'll pause right here and back. Okay, the first example I'm going to do is number 9. They give us A, B, and C, all small letters. So small a, small b, small c, which in our triangle is the side lengths. So that automatically tells us that we need to find the angles. Now, from the formulas, we have cosine of A, so cosine capital A equals b squared plus c squared minus a squared all over 2bc. Now, how I memorize these kind of formulas, which hopefully you're never asked to do, but in case you are, whatever A you're finding, either small or big A, if I'm finding the area or the angle of capital A, I know that it's just, these stay the same, add those. My only other A, small a, is the minus at the very top. Okay, so as you can see, it's just a bunch of numbers, so let's plug them in. So 15 squared, 21 squared, all minus 11 squared, all divided by 2 times 15 times 21. So, if you're not, some people are very bad plugging stuff into the calculator, so take your time. 225 plus 441 minus 121 all over 630, okay? Go ahead and add all that stuff together. For some of my students, I highly suggest this stuff, and because if you were to plug it all in your calculator, let me say it this way, if you plug everything in your calculator and you mess up on any kind of parentheses, it messes up your whole answer. So, unless you're really good at recognizing parentheses, which if you were, you need to make sure you have your parentheses all like that. Again, a lot of students forget it and a lot of them mess it up. So, that's what we get there. We ended up with 545 over 630. That equals cosine A. And remember, we want an angle measurement. To find the angle measurement, we take the cosine inverse. I have a lot of students who mess up on this stuff. Whenever I want an angle measurement, so whenever I have a variable here, I have to take the cosine inverse of this over here. I can't divide a cosine. I can't say cosine of this number. I have to go like this. A equals that. Okay, so get our calculator. Cosine inverse. It would help if you went your internet. And we get this is about 30 degrees. So make sure you're in the right mode, which you should be in degree mode. I'm going to check my answer with the book. Make sure I did it right. You should get 30.1, 30.11 in case you round up. Depends where you round up at. The less you round, the more accurate it's going to be, of course. But that's for angle A. So let's just go ahead and put it over here. Angle A. So this is what we found. Okay, angle A. 30.11. I want to find B and C. All right. So I'm going to erase all this. Now, I want to find B. So I'm going to say cosine of B. Again, like I said, well, I always know that I'm going to subtract it over here. So let's interchange my B's with A's. So A, B, and A. All right. Now, of course, I will say this. You are welcome to use law of sines as well if you want to get to this point. Because you have an angle, and you have one, that side that corresponds to that angle. We have this angle, have this side, we need to find this angle. You're welcome to use law of sines. This is the same idea. I'm going to use law of cosines because, well, that's what the lesson calls for. Of course, it's up to you and what you want to use. So I'm going to plug in my numbers. We should get all that in there, so let's just go ahead and plug all that in again. So we're going to get 121 plus 441 minus 225 all over 462. All right, so let's go ahead and add all that up. We get 337 over 462. And remember, this is cosine of B now. All right, remember, we want the angle measurement, so we do the cosine inverse. Cosine inverse of so equals 43.16. Let me check what they got. Same thing. We'll go with that. All right. So, of course, you could do it one more time, or you could use the knowledge, hopefully, the shortcut. You only need one more angle. You know all three angles need to add up to 180. So, to find angle C, that's 180 minus 30.11 plus 43.16. get C, equals that. Again, you're welcome to use law of cosine finding the C. Of course, do not suggest that. It takes up too much time, as one of my students likes to say. This is easy, it's just time consuming. So as you can see, that's law of cosines given all three sides. All right, so let's move on to another example, and I'm going to do number 13 out of my book. This one, they give us angle A is 120 degrees. Then they give us small b equals 6, and small c equals 7. So what we want to find, okay, and again, I like listing stuff out. It makes it a little easier for a tracker. I need to find small a. I need to find capital B. And capital C, okay? So this is one where we're given one angle and two sides. So what we need to do, we're side angle side, if you were to draw a triangle, that means we're going to use a squared. I'm going to find the other side first. Equals b squared plus c squared minus 2bc cosine of A. Alright? Again, I've just worked with a lot of it, and I'm good at memorizing formulas. But again, whatever letter I need to find here, that's the cosine of the angle. So, let's plug everything we got in. So 6 squared plus 7 squared minus 2 times 6 times 7 times cosine of 120. Alright, so that means we're going to get 36 plus 49 minus 84 cosine 120. Now let's go to our calculator. So 36 plus 49 minus 84 cosine 120. Enter, and a squared equals 127. Do not forget to take the square root. Equals 11.27. Okay, so let's go find angle B now. Again, you're welcome to use law of sines if you're more comfortable with that. But for the lesson, I'm going to use law of cosines. Alright, so I want to find angle B, so that's cosine of B equals a squared plus c squared minus b squared, small b squared, all over 2ac. Okay. So let's plug in what we've got, even with our new a, even though we did round it up, so it might skew some answers depending on your answer book, whatever you're using, or when you check it. I have this motto, if you're within plus or minus 1.5 of the answer, then I'm going to give you credit for it. Also, basically, if you just show me your work, and hopefully that's usually true with all math teachers, if you just show your work, usually you're going to get close to that. I'm assuming it's not multiple choice, which just depends on your teacher and stuff like that. But with me, if you're within plus or minus 1.5 of the answer, you're good to go. So we get 6 squared, we get 11.27 squared, which think about it, you already answered from the previous problem. Just use that number, makes your life a little easier. So then we get 7 squared minus 6 squared all over 211.27 all over 7. Yeah, what I would do then, since if you guys go back whenever we found a squared, we already found that. This should just equal 127. I know if I plug that in my calculator, it won't be that. But if you go from the properties beforehand, when I found little a, it was a squared. So there's that. Let's plug that in the calculator too. Look at this huge mess, so I'm going to add that together real quick. Get 140 over 157.78. Okay, now remember, we want to find the angle, so this is cosine of B. Now what I want to find the angle means cosine inverse. Alright, so let's go ahead and plug that into our calculator. And this equals, or nice, 27.46. Okay, again, I just need to find another angle C. So what I'm going to do is angle C equals 180 minus 120 plus this new number we found. And when I get C equals a nice 32.54. Okay, I check my answers. 13, that's what they got to. So there's two examples of law of cosines. They're two different examples, but it is pretty easy. You just plug it in and go. So that's it for law of cosines. Actually, sorry, I was going to show Heron's formula. So let me give it a break. So all right. Sorry about that. So here's Heron's formula, which if you're following from the book, it's page 440 if you have the same book we do. It is the square root. Now, okay, let me start. This formula works if you have 3 given sides. All right. So this is the square root of s times s minus a times s minus b times s minus c, where s is equal to a plus b plus c all divided by 2. All right. Again, plug in, go. So, I'm going to do number 33. It's in our book. So we have 8, 12, and 17. First thing I do, find s. All right. So s, I'm sorry, they look like, my s's look like 5s. You can tell there's no 5s in this answer. So, 8 plus 12 plus 17, all divided by 2. Simple math is very bad. And we get s equals 18.5. Alright, so now let's find the area of it. So the square root, so a, the square root of 18.5. No, 18.5 minus 8. 18.5 minus 12. And 18.5 minus 17. Now let's just go ahead and plug it into our calculator. So 18.5 times 18.5 minus 8, close parentheses, times 18.5 minus 12, close parentheses, and then 18.5 minus 17, close parentheses, and then close parentheses last, so just let you have it. And you get 43.5 or 5.2. Let me check what they got. And that's what they got too. So there's Heron's area formula with law of cosines. I think with law of sines there's no oblique 1, 2, but again, it's pretty simple. You plug in and go. So overall, law of cosines is really easy. You plug and go and plug what you have into an equation. Same with law of sines. Just moving stuff around and recognizing cosine inverse. That's the biggest thing I've noticed with my students. So hopefully this helps, and good luck with it.